Hey guys, today we'll be looking at the effects of the parameter h given quadratic functions in vertex form. So here's today's FLT. Given a quadratic function in vertex form, I will be able to describe the effects of h. So for the upcoming few lessons, we will be focusing on transformations of functions. So we will be looking at how quadratic functions can be transformed based on our parameters. So when we're thinking about transformations, this is the main question we want to think about. How does the graph of the function move? So this is the graph of our parent function, or our base function, f of x equals x squared. In the upcoming lessons, we're going to look at how the given functions move compared to the original parent function. So we will be describing the movement. So first, we're going to focus on translations. Translations are a type of transformations, and when you translate something in math, you move it from one place to another. If you were in Math 1 last year, you've actually seen translations. Remember how we would translate triangles from one spot to another spot. Translating quadratic functions is a very similar idea. We will be talking about how to translate the function from the original parent function. So again, how is our function moving? So today, we will be focusing on the effects of h. What does the parameter h tell us? For the past few lessons, you've been seeing quadratic functions written in vertex form. So f of x equals a times x minus h quantity squared plus k. But today, we're just going to focus on h. So we're going to ignore the parameters a and k and just focus on h for today. So today we will be looking at simplified versions of quadratic functions in vertex form, where f of x equals x minus h quantity squared. Remember, today, we're only focusing on h. Our main question for today is, what does h tell us? Here, I'm on Desmos, and I have the graph of the parent function, f of x equals x squared, and I also have a quadratic function with the parameter h. Let's see what happens as h becomes more positive. And And then what happens as h becomes more negative? So as you may have noticed, h gives us our horizontal translation. It tells us whether to move to the left or to the right. So if h is positive, translate your function to the right. You will move to the right if h is positive. And if h is negative, you will translate to the left. You will move to the left if h is negative. Using this information, let's take a look at a few examples. For our first example, we will describe the transformation of this function, f of x equals x minus 3 quantity squared. As usual, let's compare it to our general form to see if we have an exact match. We're focusing on h today, so we ignore a and k. So I have f of x equals x minus h quantity squared. I have an exact match, and I also notice that h is replaced by 3. For this function, h equals positive 3, so we will move the function to the right. So we need to provide a description that would look like this. Since it's a quadratic function, we have a parabola that translates, so that moves or translates 3 units to the right because h equals positive 3. So from the parent function, we move 3 units to the right. On Desmos, it would look like this. Notice how we moved the function or the parabola 3 units to the right from the original parent function. For example 2, we will describe the transformation of the function f of x equals x minus 6 quantity squared. First, I want to find the h value by comparing this function with the general form. F of x equals x minus h quantity squared. We have an exact match, and h is replaced by 6. So in this problem, h equals positive 6, so we will move to the right. Again, since h is positive, we move to the right. So we will be describing this movement. We have a parabola that translates six units to the right, again because h equals positive 6. So compared to the parent function, we shift our parabola 6 units to the right, like we see in this Desmos graph. For example 3, please choose the correct description out of your choices provided on Edpuzzle. You will describe the transformation of f of x equals x minus 4 quantity squared. For our next example, we will describe the transformation of g of x equals x plus 1 quantity squared. The general form is g of x equals x minus h quantity squared. Notice we do not have an exact match, so we need to rewrite the given function. G of x equals x minus negative 1 quantity squared. Now I know h is replaced by negative 1, so h equals negative 1. Since h is negative, we will move to the left. So again, we need to provide a description. So we have a parabola that translates one unit to the left because h equals negative 1. So compared to the original parent function, we would move this parabola 1 unit to the left, again because h is negative. We check on Desmos to see that this parabola is moved 1 unit to the left. Let's do one more example together. Describe the transformation of g of x equals x plus 5 quantity squared. What is our h value here? I write the general form g of x equals x minus h quantity squared. I do not have an exact match, so I need to rewrite this function. I have g of x equals x minus negative 5 quantity squared. H is replaced by negative 5, so I know h equals negative 5. Since h is negative, we will move to the left. We have a parabola that translates five units to the left because h equals negative 5. So I have a parabola that translates 5 units to the left. Again, you can check your work on Desmos and see that we do move the function 5 units to the left. Please try this last example on Edpuzzle. Describe the transformation of g of x equals x plus 9 quantity squared. The vertex form of a quadratic function is f of x equals a times x minus h quantity squared plus k. But today, we just focused on h. H gives you the horizontal translation. It tells you to move left or right. If h is positive, translate your function to the right. If h is negative, translate your function to the left. Great job today, and please make sure to submit your notes on Canvas.